In this question, we're given some compounds that are listed in the first column, and then we're given the important species when dissolved in water, and we're asked for several things. Is it ionic or molecular? Is it a strong acid, a weak acid, a strong base, or a weak base? So let's look at the first one. We have NaBr. That's clearly an ionic compound. It contains a metal and a nonmetal. So that part is easy. How about its acid or base properties? Well, NaBr is a salt. You get Na plus and Br minus. There's no proton transfers here, so you have Na plus, Br minus, and water. So it is not any of these things. It's not an acid or a base. Remember that acids donate protons, and bases accept them. NaBr does neither. Let's look at the next example, C2H5NH2. This is called ethyl amine. This is clearly a molecular or covalent compound. It does not contain any metals. Now let's look at its acid or base properties. When we dissolve it in water, we get C2H5NH3+. Notice this has one extra H and a plus charge, which means this molecule has acted as a base and taken a proton from water. Of course, we also get OH-, which is what's left over when you take a proton away from water. Another important thing to notice is we also have the original compound. We have C2H5NH2. So we know it's a base because it took a proton away from water. We know it's a weak base because it didn't do it completely. So therefore, this original base is still in solution. So we both have, if you will, the weak base and its conjugate acid. So this is a weak base. Let's look at the next example. HNO2. Again, no metal, so this is molecular or covalent. Now let's look at its acid or base properties. When we put it into water, we get H3O plus and NO2 minus. So HNO2 donates a proton to water to form H3O plus, and what's left is NO2 minus. So we know it's an acid because it donated a proton. Now we have to decide if it's strong or weak. Well, if it's a strong acid, there shouldn't be any HNO2 in solution. It should all be NO2 minus. When we see that there's HNO2 in solution, we know that it's a weak acid because it didn't dissociate completely. Let's look at the last example. HBr. HBr is the same. It does not contain a metal, so it's molecular or covalent. Now let's see what happens when we put it in water. We get H3O plus, as HBr, hydrobromic acid, donates a proton to water. What's left over is Br minus, and of course we always have water in solution in all cases. Notice there's no HBr present in solution. Since there's not a significant amount of HBr, that means HBr is a strong acid, or it protonates water completely, or it dissociates completely in water. So that's how we can identify. To review briefly, ionic salts that don't gain or lose protons are simply ionic and have no acid-base properties. Weak bases don't accept protons and they're still present in solution. Weak acids donate protons to water and they're still present in solution. And strong acids donate protons to water and there's none of the original acid in solution. So that's how you can tell what's going on here.